this assessment, we're asked to predict the product of an acid-base reaction. And to do that, we're asked to identify the acid and the base, identify the most electron-rich portion of the base, and identify the most acidic proton of the acid. By doing those things, we can then draw an arrow-pushing mechanism that predicts product formation. Well, we can start by looking at the acetylide ion, this molecule here, with a negative charge on carbon. Having a negative charge is a big indicator that the acetylide ion is probably going to be our base. And if we draw in the lone pairs based on the formal charge of -1, we know that there's going to be a lone pair on that carbon. HBr, named hydrobromic acid, has a hydrogen attached to a very large, somewhat electronegative atom. As a result, HBr is going to be the acid. We can draw in the lone pairs here as well. This analysis that recognizes that carbon has a negative charge and a lone pair, and the bromide has an acidic proton attached, tells us not only that this is the base and this is the acid, but it kind of suggests what this mechanism is going to involve. And that is our base removing the proton from HBr using our arrows drawn that way. What we're showing is the lone pair of electrons being donated to this proton, and at the same time, the electrons in the HBr bond moving on to the bromide. By accounting for that electron movement, we can predict the products. This lone pair will become a new bond between hydrogen and carbon. And so our product, the conjugate acid, will be this molecule, acetylene. Doing the same thing for the bromide, we see that bromine has 3 lone pairs, and when these electrons move on, we'll create a 4th lone pair. And so we end up with this as our conjugate base and the other product. Now bromine with 4 lone pairs is going to have a negative charge. And so this makes sense because on the left side of our equation, we had a negatively charged molecule plus a neutral molecule. We would expect to get a total of a -1 charge over here, and we have that, acetylene being neutral and bromide having a -1 charge.